Right. I give you another 5 minutes or so to log into your attendance. Thank you. Before we start the class, eh? Thank you. Okay, everyone. I'm going to share the QR code attendance again after this. I think we better start our class then, so that we can finish everything in time. Attendance is a lot lesser today. I think everybody is still having this Hari Raya mode. Anyway, this session is recorded, so then again, it will be shared in evening. Okay, thank you very much, everyone. Before we start, I would like to wish you all Selamat Hari Raya Aidilfitri, Ma'azai Batin. Okay, so today we're going to start our lecture, LU5, where we're going to discuss about energy from solid and liquid waste. All right. Shall I start the class then? Okay, everyone? You all okay? Okay. Okay, thank you, thank you. Okay, I'm going to stop sharing the QR code attendance. And then maybe in between, I will share again the QR code attendance. Eh? All right, thank you. Right. Okay, this is the topic that we can discuss today, LU5, where we're going to focus on energy from solid and liquid waste. When discussing about this lecture, it's all about something to do with what do you call it? Getting this zero waste production as well as utilizing fully the waste resources to be able to produce something useful, in this case, in the form of energy. Okay, so bear in mind that any solid or liquid waste is able to be reused again to generate, okay, energy, right? So this is also something to do with the new term about is circular economy. Okay, circular economy meaning to say that anything is not, everything is being used up, none is being wasted. Okay, so here when we discuss about this energy production from solid and liquid waste, uh, biotechnology play a major role in getting this to be converted successfully and also fully into energy. A glimpse about how waste being what got generated and then converted to energy would be this diagram. As you can see here, you can have a combustion or incineration that generates the heat, and then this heat is can be what got converted to the form of energy. Even organic waste again going through anaerobic digestion, producing those biogases, and then these biogases again being converted to produce energy as well as or what you call it, green fuel, either in the form of what do you call it, bioethanol, or in the form of what do you call it, biodiesel. Biodiesel, the difference between biodiesel and bioethanol is that the biodiesel is not really 100% something that is green. Okay, it's a mixture of what do you call it, diesel, the organic fuel, as well as the green fuel. Okay, so it's not totally 100% green fuel for biodiesel. It's a mixture between the two. But then again, the portion will be a lot lesser for the organic, what do you call it, diesel. Okay, right. So we're going to discuss this topic today, where we're going to look into how energy being generated and produced from the solid and liquid waste that contributes to the circular economy. Okay, circular economy. I have a few journals paper or review paper, the very most recent one that I will share with everyone that highlighted the current what do you call it, situation, the current progress as well as the challenges when it comes to production of energy from solid and liquid waste. All right. So let us start with our lecture today that focuses on this energy from solid and liquid waste. Hang on, sorry. Right. When we discuss about this one, can you all see the slides here? The slide is available. No, it's not shared, isn't it? So the slide is not shared. Hang on. Okay. All right. Okay. So when we discuss about this, what do you call energy, how is this energy being produced? Okay. So we're going to focus on these two parts: how energy being produced from solid waste, the processes involved like direct combustion, co-firing, gasification, as well as cogeneration. Okay, and that one is on solid. We're going to also discuss about energy production from liquid waste. Okay, looking into the principle of the system, what are the raw materials for the biogas production, specifically methane. Okay, the prospect of anaerobic digestion, key steps in biogas production, classification, construction, as well as operation of the digester, which is very important when it comes to energy production from liquid waste. Okay, and then the operation of the digester as well as the byproduct produced from this so-called anaerobic digestion. Okay, for all you know, energy production from solid and also liquid waste is not really something that is new to our country. Okay, we have already the technology in place. Okay, so you'll be surprised that some of those what do you call it, oil palm or what do you call it, agriculture, what do you call it, plant, they have already in place the technology that utilizes their respective solid and liquid agricultural green waste. Okay, especially the oil palm industry, they have that in place already that help to generate energy to the plant itself. Okay, so these are the technology that we're going to be familiar with, we're going to look into it, and then we're going to understand better how energy being produced from both solid and also liquid waste. Okay. Right. First, let's have a look into the energy production from solid waste. Okay, as you can see here, the solid waste, the one that is being dumped, the refuse, derived fuel is an everlasting, ever increasing alternative. Okay, this energy of fuel being produced is increasingly an increasing alternative in Europe. Okay, because the problem is that in Europe, land availability for landfill is becoming more and more difficult and more restrictive. Okay, there's not much land to be able to be converted to become a landfill, to be as a dump yard for the solid waste. So therefore, the lignocellulosic biomass specifically, okay, produced and generated from trees, grasses, the agricultural byproduct, okay, food, fiber, as well as forest production, okay, and then not to forget the household waste, specifically papers. These are the examples of the most what I call it, important and economical biomass fuel for generating electricity, okay. How all these biomass being converted to generate electricity? There are four primary classes, okay, from primary classes of biopower system. Number one will be the direct combustion. Okay, this will be the direct combustion. Okay, and then number two will become one as well through this direct combustion, producing the gas. Okay, this one is a co-firing. Okay, co-firing, and then gasification, producing gas, and then cogeneration. Number one will become two. Okay, number one will become two. Okay, maybe you can't really see what I meant. Maybe we can have a look at how the Europe country, specifically in this video, Sweden, convert the garbage into energy. Okay, so let's have a look. Um, you might not be able to see this. Hang on. Hang on. I'm just going to stop sharing this for a while. I'm going to share the video. Can you all see the video?
2 billion tons of trash are dumped into landfills every year around the globe. That's so much trash that if you lined it up in garbage trucks, it could circle the earth 24 times. Wow. But Sweden has found a way to make their trash work for them. By using it to fuel a waste-to-energy program, it converts garbage into sustainable energy. Sweden has even gotten so efficient at this process that they've run out of their own trash and now import garbage from other places. Believe it or not, only 1% of Swedish garbage actually ends up in a landfill. So where does it all go? About half, or 47%, of Sweden's waste is recycled. The program recycles and sorts metals, plastics, newspapers, batteries, and electronics. The remaining 52% of the country's waste, like excluded scrap metal, circuit boards, and agricultural waste, is used for the country's Waste to Energy, or WTE program, which produces electricity from burning waste. So all that remains is a remarkable 1% of Sweden's trash that actually ends up in a landfill. But wait, how exactly does garbage turn into energy? After recyclable content has been removed, the remaining trash is brought to a waste-to-energy plant. There, the trash gets loaded into furnaces and burned, which generates a large amount of steam that spins generator turbines, producing electricity for the nation's power grid. All leftover metals are separated and recycled, while any other remaining materials that do not burn, like porcelain and tile, are collected and repurposed into gravel for road construction. Over the past decade, Sweden has become so good at this waste-to-energy process that they've actually run out of their own garbage and had to start importing it from other countries. It's a win-win situation for most countries, since shipping trash to Sweden is not only cheaper than paying landfill taxes, but it also makes sure more garbage is reused. In 2014 alone, countries like the UK and Italy exported about 2.3 million tons of waste to Sweden's WTE facility. Those factories charge about $43 per ton of trash, meaning that for those 2.3 million tons, the country made almost $100 million in revenues. Day by day, Sweden gets closer to becoming a zero-waste nation, with efforts both large and small. Their waste-to-energy program has even inspired other countries to consider it for themselves. Do you think a waste-to-energy program would be beneficial in your country? If you're looking for more ways to help save the world, click the subscribe button. Or if you want more videos from Save the World, click here to keep watching.
All right, everyone. So that one is the technology developed in Europe, specifically Sweden, where they have all the garbage being converted into what do you call it, energy. It's a form of like energy waste going into the furnace, the one that is able to be burned down into the furnace and then get incinerated, and then that produces the gases, the steam, and then this steam will be the one that uh, move the grid or move the turbine that will help generate energy. Something similar to our technology here where we use water, actually, the natural resources. Okay? Just as an example. Okay. So that will be the technology in what do you call it, Europe. Over here in our country, we're still having this system of landfill. We still have land, but then again, very soon we have to figure out ways to do this technology and make it available in our country. We have an incinerator in what hospital that deals with all those hospital waste that is being burned down, and then but then again, not so much into generating energy actually. But then again, it's good to look into the technology developed by the Swedish. Okay, that we can have it here. What we need is a company that the green company that willing to invest on this sort of technology that will help generate what they call it energy, green energy from the waste. Okay, so that is one example how all those solid waste being converted, going through what do you call it, incineration, going through incineration, direct combustion, okay, co-firing, and then producing gas and gasification, and then cogeneration. Okay, So this is the technology that is more or less being discussed just now. That is being implemented in Sweden. Okay, this is quite simple, okay, and straightforward. And then it helps to generate electricity, energy at the end. All right. At the same time, apart from producing energy, it also helps in supplying the hot water, okay, to the building as well, which is very important for the temperate countries, especially the country in the Europes that have this, what do you call it, different seasons from ours, tropical. All right. So that is example of energy production from solid waste. Okay. So looking into specifically the types of what do you call it, energy being produces, the processes. Let's have a look at one by one. We have a direct combustion. Okay, so this one deals directly the primary fuel in the form of available in nature or after some form of processing. For example, like bequeathing as well as pelleting. So we have this some sort of like after some form of processing, especially at oil palm plantation. Okay, where they have this processing plant that what do you call extract the of crude oil from oil palm, and then the waste is being converted into the form of requatering as well as pelleting, and then we have this sort of like packaging of the waste, and then now these days the oil palm plantation they help to supply this and then get it to be what we use as charcoal, the lignocellulosic waste produced from oil palm. Okay, and then this is being exported to China in particular. Okay, so the bequeathing as well as the pelleting of the lignocellulosic waste are the gasification process of the loose organic materials, specifically the lignocellulosic biomass. For example, we have a lot of rice husk here. We have a lot of sawdust. Uh, Rice husk, we don't use it much for animal food, so it's abundant. So I think it's good for some of it, apart from being what do you call it, turned into soil conditioner, will be something more value added if we can have it in the form of bequeathing as well as pelleting and then converted it to what do you call it, source of charcoal, okay, for export. And then we have some coffee husk. Coffee husk is not that much. We're not a coffee producer, but in terms of sawdust, rice husk, we are abundant of that type of resource, lignocellulosic biomass. Not to forget the what you call oil palm. So those are the biomass, lignocellulosic biomass that are abundant in our country. Okay, so all these are being converted into the bequeaths as well as the pellets, and then these are being used as what do you call it, for warming up, for warming, okay, to warm up, okay, during winter. Okay, so it's something that is simple. Okay, because all these piles of sawdust, all these piles of rice husk that you find a lot in the processing plant, this can easily be what do you call improved in terms of handling and combustion characteristics. Okay, and then convert it to be something that is handy for stove, for fireplace, for grill, and then this is actually for direct combustion. Okay, so the direct combustion of all these lignocellulosic biomass can also produce electricity. Okay, when it comes to all this material being burned in a boiler and that produce high pressure steam, and then this steam will be the one that move the turbine, okay, flow over the turbine blades, and then as a result, the kinetics energy being converted into electricity. Okay, just something similar like our hydropower, the one that we have in Bakun, where we use the water to move the turbine. Okay, something similar to that. Okay, in this case, we use the steam. Okay, this steam can also runs an engine, for example, in train. Okay, so this is something that you find very useful. Instead of dumping it into the environment, creating the unnecessary pollutants of this organic lignocellulosic waste, why not get it to be converted to something combustible and then produce able to be reused, okay, and then value added, and then produce energy in the form of heat as well as in form of electricity. All right. Okay. Next, we have co-firing. Okay, what is meant by co-firing? Um, Co-firing will be referring to the use of the biomass. Okay, the wood chips, the what do you call it? The sago trunk. For example, this is a sago trunk, I think, and then what do you call it? Waste. So what do you call it? Wood waste. Okay, wood waste. Okay, so you use all these lignocellulosic biomass and to replace some portion of coal in the coal power plant. Okay, you have the coal power plant. So you use some of the lignocellulosic biomass together with the coal. This one will help reduce the amount and usage of coal in the burner. So you have the mix of both the lignocellulosic waste biomass together with the coal. Okay, so normally examples like this we find it quite what do you call it quite frequent, okay, in some of those oil palm plantation and also in sago mill, okay, whereby they use the sago bark as well as the wood waste in combination of coal or fuel like diesel. So this will help in cutting down the drying cost, because for sago processing you need to dry the wet sago flour, so it needs to be it requires the use of heat. So this is where the sago bark trunk, or wood waste is being used together with the coal and also the diesel fuel to generate heat, to heat up the sago flour to get it dry. That will help cut and reduce the cost of the drying process. Okay, there will be some loss in terms of the efficiencies when it comes to the use of the biomass, but then again, this is being balanced equally by the cost of the process that's been cut down with the use of the biomass resources. Okay, lignocellulosic biomass resources. For coal, the most effective substitution can be made within the range of 10 to 15% of sago bark being used together with the coal, and then this is also important too and detrimental for the metal piping. Okay, so this is meant by co-firing, the mix of biomass together with the coal as well as the diesel to generate the heat that is required for the drying of the sago flour. Okay. Okay, and then next we have gasification. Gasification will be the process that converts the carbonaceous material. Okay, for example, the coal, petrol, diesel, biofuel, or biomass into carbon monoxide. and also hydrogen. How it's being converted into carbon monoxide and hydrogen is through the burning of the raw material. For example, the lignocellulosic biomass, the wood, and also the compost, sago bark, as well as the household house waste. Okay, get it burned at high temperature with a controlled amount of oxygen, and you can have it combined or together with the production of steam. Okay, so the resulting gas mixture production will be referred to as the synthesis gas or syngas. Okay, and then the syngas itself is a form of fuel. Okay, so the process itself, the gasification, is referred to as a method for extracting energy from many different types of organic materials. For example, here, lignocellulosic biomass or any other types of organic waste. Okay, so you can have it, what do you call it, converted, okay, into carbon monoxide and also production of hydrogen. Okay, so the advantages of this gasification process is that using this syngas produced, okay, it is much more potentially more efficient as compared to the direct combustion of the wood waste, because in the gasification, it is going to be mixed first with oxygen or air, and then get it combusted at high temperature. So the syngas produced may be burned directly in the internal combustion engine, and also at the end will help to produce energy from the steam generators. Okay, so there are different stages whereby you have stage one, okay, and then stage two, the burning of first the burning of wood, the wood drying and also degassing. Okay, and then stage two will be the burning of the mixed wood gases with secondary air temperature. And then the third stage will be the flame that reheating at a much higher temperature of about 1200 degrees Celsius. And then from there, it goes to stage four, whereby the combustion gases will be ejected by the chimney. Okay, so you have this process whereby you produce the biomass gasification. Okay, and you have this wood undergo combustion with the supplementation of air to help it to be burned down and get the what do you call it, the volume to be reduced further, and then produces gas, and then this gas will be the one that what do you call it, connected to the boiler that produce the steam, and then the steam will be the one that move the turbine that helps the generator in generating the electricity. Okay, that will be the whole process in gasification. So the advantages of this gas mixture is it's a combination of what you call extracting energy from many different types of organic materials. Right? So that would be the gasification. We have already discussed about direct combustion. We have already discussed about coal firing, combination of coal and also diesel with other types of lignocellulosic biomass. And then we have gasification, the production of biogas that will produce heat, and then this heat will be the one that what do you call it, converts water to steam, and then it will be used to further move the turbine. Okay, that will be the whole process. Okay, and then in current situation, small businesses as well as a building application where the wood resources are very much abundant and available and sustainable. So there is this new zero carbon biomass gasification plant that has already been installed in place in Europe. They produce the tar-free syngas from wood and then burn it into engine connected to the generator for the heat recovery process. Okay, so it is a form of a potential renewable energy. Okay, because gasification can proceed from just about any type of organic material available, including the biomass and also the plastic waste. So the resulting syngas, the biogas, uh, can be combusted, and then this, if it's clean enough, then again it can be used as for power production and gas engines, gas turbine, and even fuel cells. Okay, or converted efficiently to dimethyl ether. Okay, by methanol dehydration. Okay, or methane from Sabatier reaction, as well as diesel-like synthetic fuel from Fisher fish process. Okay, so there are all sort of what do you call it, byproducts that is available for production through this gasification process. Okay, so in our country, uh, the solid and also the liquid waste can be used, okay, to generate energy. In this case, we are focusing on abundant lignocellulosic biomass that is available in our country. Okay, right. So next, okay, these are some of the local gasification process available in Cebu. Cebu is very famous of timber industries. Okay, so they have abundant sources of lignocellulosic biomass. So they have these gasifying units available. Okay, and then filter to purify the syngas produced, and then syngas when lighted will have this connected to autoclave unit, and also some sterilized mushroom media available also, okay, in the local gasification process. Okay, so this is something interesting, a small scale, but then again still be able to produce something that is value added, and also generating heat and also what do you call it, energy. All right. So last we have cogeneration under the energy production from solid waste, the process. What is cogeneration is all about is something to do with combined heat and also power. Okay, cogeneration combine the heat and also the power. So this cogeneration is all about the use of a heat engine or power station in order to simultaneously generate both electricity and then useful heat, something that is being practiced and implemented in Sego processing plant, in Muka, in Dalat, as well as in Oya. Okay, the one that has abundant sources of Sego palm and also Pusa as well in Serato. Okay, so this cogeneration, combined heat and power, okay, reduces the process reduces the emission of greenhouse gases, okay, which contributes to global climate change. Okay, so therefore, when electricity is being produced on site using this cogeneration, combined heat and power plant, so excess heat is going to be recycled to produce both process heat and also additional what you call power. Okay, so nothing is being gone through into waste. Nothing is being what you call released and then not being utilized fully. So meaning to say this is something to do with the circular economy. Okay. So the end theme is the circular economy. So conventional power plant that emits heat created as the byproduct of the electricity generation into environment through the cooling tower, and then you have the fuel gas or by any other means. Okay. However, with the cogeneration or combined heat and power in place, this will help capture all the byproducts in the form of heat for domestic and also for industrial heating purposes. Okay, either it is very close to the plant, okay, or you can have this hot water from for district heating, okay, with the temperature ranging from 80 to 130 degrees Celsius. Okay, so you have this, okay, something interesting that you can look into, okay, whereby with the conventional method, you have the heat is being released as the byproduct during the electricity generation. But then again, with the cogeneration, the combined heat and power process, okay, this will help to capture all the heat generated, and then this heat is being channeled for domestic as well as industrial heating purposes, and then for district heating even with temperature high temperature ranging from 80 to 130 degrees Celsius. Okay, as you can see, you have this. Some of the waste is being used for production of bitumen. Okay, and then at the same time producing energy in the form of electricity and also heat. Okay, that will be used to for warming process, right? That will be the cogeneration. So we discussed the four process under the energy production from solid waste, the direct combustion, the co-firing, the gasification, as well as the cogeneration. So I hope you get an idea about the whole of this about all of the processes involved in the conversion uh, or generation of energy from the solid waste. Okay, right. So this is a cogeneration plant in Denmark. Where you find this cogeneration process is thermodynamically efficient for use of fuel. Okay, so the thermal power plant using this fissile elements of burn coal, petroleum, as well as natural gases do not convert all the thermal energy into electricity. So therefore, by capturing the excess heat, the combined heat and power process uses the heat generated uh, to be something meaningful. Okay, so uh, not much is being wasted as compared to the conventional power plant. Okay, meaning to say less fuel is being needed to be consumed to produce the same amount of useful energy needed. Okay, so a car engine becomes a combined heat and power plant in the winter when when the heat release is important and useful for the warming of the interior of the vehicles. Okay, so this is one very simple example that illustrates the deployment of the CHP. Okay, and then in US, a company like Con Edison distributed 20 billion kilogram of just steam, 100 degrees Celsius steam each year through its seven numbers of cogeneration plant. And then this is being supplied to 100,000 building in Manhattan. Okay, so the steam distribution process is the reason for steaming manholes. Normally you get to see this steaming manhole available in some of the movies, like the one that shown here, the famous Marilyn Monroe movie. Okay. So back here in Malaysia, in our country, we have plentiful of this lignocellulosic biomass, especially the oil palm plantation. Not to forget the what do you call it, the sago waste, the sago bark being dumped at the plant factory yard, and then this being used as the what do you call it, in the co-firing process. The same goes to the waste produced from paper, okay, and then wood product, okay. All this can be reused, recycled, either to for direct combustion into bickering or pellets, coal, and etc. Okay? So you can think of some ways, some ways whereby, hang on, you can think of some ways whereby we can have this for our local scenario. How we be able to use the processes, be it the direct combustion, be it the what do you call it, co-firing, be it the what do you call it, gasification, as well as cogeneration. All these are already, some of it is already being implemented in our plant as well. So maybe it's high time for everyone to think of a simple but yet efficient technology that can be applied to our local scenario. Okay, sago, what we call it, plantation, a sago plant processing has already been implementing the co-firing. Okay, and maybe we can think of something else that can be used. There are various type of feed materials. Okay, and then looking into the advantages of the respective processes involved, that will help in the circular economy. Okay, circular economy. Okay, so that will be on what do you call it, energy from solid waste. Okay, energy from solid. Next, we move on to energy production from liquid waste. Liquid waste. Okay, so for energy production from liquid waste, let's have a look at the principle of the process involved. Okay, so you have agricultural waste. Okay, some of it contain combustible materials, uh, meaning to say that all agricultural waste are not actually really waste, but it is in the form of organic carbon and nitrogen. And therefore, it is an excellent substrate for further product formation under microbial process development. This is referring to natural process of fermentation, okay, or digestion, or degradation, biodegradation. Okay, so in rural communities, the process of recycling the human, the animal, and also the vegetable waste has been practiced for centuries by men, and then providing even valuable fertilizer as well as biofuel in the form of biogas as well. Okay, of course, 70% of the biogas generated from this microbiological process are methane. Methane. So, during my childhood, okay, next to my house, there is this big tank. Like in the old days, we have this big tank, very huge tank where you get to uh, what do you call it? All those dump from the toilet will go into that big tank. Okay, so if you stand on this big tank, you can feel the warmth, the heat generated. can feel the heat generated when you stand on top of that huge cement tank. You can feel the heat generated, and then also the production of the gas. Yeah, that is the biogas, the methane. Uh, because the waste, the organic waste produces being what do you call it, converted and undergo anaerobic digestion process by a series of microbes involved. They break down all these biodegradable materials in the absence of oxygen. And then this anaerobic digestion has been widely used to treat what do you call it, wastewater, especially the black wastewater or gray wastewater. Okay, so as part of the integrated waste management system, the process of anaerobic digestion is important to help reduce the emission of landfill gas into the atmosphere. Okay? So some of the process involved. Mm, this is a street lamp in London where it is light using the biogas as the fuel. Okay, as you can see here, the what you call manure from animal is being collected into this biogas generator. Okay, and then this gas generator, biogas generator will be the one that would undergo and perform the anaerobic digestion process, and then gets to produce and release methane. So that then again, this methane is being burned down for cooking as well as heating. Okay, and then the carbon dioxide is going to be released into the atmosphere and then captured by plant through photosynthesis process, and then eat by animal producing manure. And then this is something like a natural process. Okay, involved. So you are emitting a natural process to fully utilize it to produce whatever that is needed. As in this case, will be energy, and then production of biogas, apart from the other byproducts produced in the form of biofertilizer. Okay, so what are the sources? Okay, the sources for this anaerobic digestion will be anything, anything that is what do you call it? Anything that is organic. This can be used and processed to produce and undergo anaerobic digestion. All those kitchen waste, okay, household waste, okay, organic waste, okay, green waste, okay, all these can be and used as organic materials and processed through anaerobic digestion. So this includes the biodegradable waste materials like waste paper, grass clipping, okay, garden waste, leftover food, sewage, as well as animal waste. Okay, so you have the pineapple waste, solid pineapple waste, producing fiber, cellulose, sugar, organic acid. You have sugarcane waste. Okay, if and then also the distillery waste, the molasses as well as the sugar, starch wastewater. These are all the form of what do you call it, liquid waste. Okay, a slaughterhouse, you have proteins, fish cannery, you have protein again, and undigested plant residues, animal and human feces, and also the market waste. Even if you go to Satok even, okay, where we have the Satok during a Sunday market, there's a lot of this green waste being produced and generated. Okay, so all in all, this will be used is and can be used for anaerobic digestion that helps to produce the biological methane. Okay, so this biological methane actually occurs naturally in almost all the almost all under an anaerobic environment where it undergoes the degradation, decomposition, okay, by highly specialized groups of bacteria that converts into this green waste or organic materials into fermentation product. In this case, will be carbon dioxide. It can be hydrogen, formate as well as acetate to the form of methane. Okay, and methane together with carbon dioxide. Okay, that will be the what we call sources, and then biogas produced from the organic waste. Okay. Next, we have prospect of this anaerobic digestion. What are the advantages as well as disadvantages of the process? Okay. If you look carefully, when it comes to advantages, the anaerobic digestion produces a low amount of biological sludge. Okay, so it reduces the volume. Okay, 3 to 20 times less compared to the anaerobic process that requires a huge area. Okay, this is due to lower energy yield of the anaerobic bacteria. Okay, meaning to say it has low biomass or low cell growth. Okay, so the good thing about this anaerobic digestion is it produces a lower amount of biological sludge. Less biological sludge is being produced and generated. Okay, meaning most of the organic waste are being successfully decomposed and also degraded. Okay, so this anaerobic digestion helps to produce methane gas. Okay, methane gas, which contains about 90% energy, and then this methane gas can be burned on site. That produces heat for the digester and also to generate electricity. Okay, again, producing heat as well as electricity. Okay, okay, with the anaerobic digestion in place, it reduces further the need to use fossil fuel and also solve the problem of methane greenhouse gas emission from the landfill. So all this methane is being used up, okay, to produce heat and also electricity. Okay, and then when it comes to anaerobic digestion, it is also interesting that this anaerobic digestion is suitable for high strength industrial waste. Okay, and then to include further, the anaerobic digestion process produces inoffensive residual sludge as the end product, and then the residual sludge can be harvested and then used as soil conditioner or biofertilizer. Okay, so everything is not dumped, everything is being used up and then returned back to the nature. Okay, so you have this process of collecting of all those what do you call it, toilet waste into this digester. Okay, and then they have this glass holder. Okay, this one is collecting all the feces from animal. Okay, and get it mixed together and then transported further into the digester. Okay, and the digester will be the one that produces the gas. Okay, and then some of the residual sludge from the digester can be used as soil conditioner or biofertilizer. So as you can see here, the digester helps collect everything. Okay, household waste, toilet waste, okay, and then garden waste, okay, and help it to be collected. So that reduces uh, the requirement for green fossil fuel gas, fossil fuel, the cutting down of trees for energy, okay, and then production of harmful gases. Okay? So, in a way that this anaerobic digestion is something, a process that really a natural process. Okay. However, there's a long list of advantages. There are also disadvantages of this anaerobic digestion. Okay. Of course, when it comes to utilizing and using microbes, it's a slow process. It's a slow process. Okay, compared to aerobic digestion, where it requires oxygen, the rate of reaction is and synthesis will be much higher. Okay, so in the case of anaerobic digestion, it's a slow process. Okay, and the rate of reaction and synthesis is much lower. Okay, so that's why you have every household you have this sort of like digester in place that helps in digesting all those organic waste and then reducing the gases and also the clean water once the process of degradation completed. Okay, and then the anaerobic digestion is also very sensitive to upsets by uh, the presence of toxicant, especially when it comes to the process is it's called anaerobic digestion. So once you have oxygen there, that will uh, slow down the process of anaerobic digestion. Okay, and then startup of the process also requires a long period of time as well. It's a slow process actually, but then again, it it's waiting, worth waiting, and then it doesn't require much of high-end sort of energy what do you call it, instrumentation or things in place. So that is the advantages of anaerobic digestion. Okay, so these are some of the what do you call it, steps in biogas production. You get to see the anaerobic digester for forming palm oil mill effluent, which is available in our country. That in most of the oil palm plantation plant, they have this anaerobic digester. Okay, this is the underground anaerobic digester unit with the circular gas collector and then fitted anti-light power point. And then this is something simple available at home. Okay, and then this is the filling of the anaerobic digester in Holland. So you have the animal waste combined with water undergo anaerobic digestion that will produce the biogas as well as the residual sludge in the form of biofertilizer, which is high in nitrogen, phosphate, as well as kalium. Okay, so this anaerobic digestion is widely used as renewable energy sources. Okay, because it helps to produce methane and carbon dioxide rich biogas, which is then suitable for energy production and then help in supplementing or replacing further, reducing and replacing further the use of fossil fuel. And then the byproduct, the nutrient-rich digested, the residual sludge, can be further used as a source of biofertilizer that is rich in nitrogen, rich in phosphate, as well as kalium. So normally in developing countries, a simple home and also farm-based anaerobic digester system are available that offers the potential of cheap, low-cost energy for cooking and also lighting. So in 1975, from 1975, China and also India have both large had large government backup scheme for the implementation and adaptation of the small biogas plant for use in the household when it comes to cooking as well as lighting. Okay, something similar to the natural gas tank that we have at home at the moment for you to do the cooking, for your mom to do the cooking. Yeah? Okay. So if you look into the process itself, the microbiology of methane formation is quite complex. Okay, you have the what do you call it, hydrolysis, the biodegradation of the macromolecules, the carbohydrate, the fat, the proteins into a simple molecules to micromolecules, the sugars, the fatty acid, as well as the amino acid. So it undergoes different process, and then production of carbonic acid as well as alcohol, and then also at the same time it produces hydrogen, carbon dioxide, as well as ammonia. So there is process of hydrolysis, acetogenesis, as well as methanogenesis for the production of methanol. Okay, so the hydrogen, the carbon dioxide, as well as the acetic acid will be the one that is used to produce what we call methane and also the carbon dioxide. So there are these four common processes. The hydrolysis that's referred to liquefaction, where it hydrolyzes all those macromolecules, the polymeric substances. Okay, and then all these organic are in the form of solid will be broken down to smaller sizes to ease the process of biodegradation. Okay, and then it's mixed and liquefied with external enzyme produced by the microbes and then dissolved in water. So this will help to hydrolyze further the polysaccharides, the fats, the protein. So you have the cellulase enzyme that degrades the polysaccharides, the what do you call it, the fat, the enzyme lipase degrades the fats, the protease that degrades the protein. Okay, so the rate of degradation of all these macromolecules, the polymers, will be the one that influence the rate of the bacterial growth. Okay, because bacterial growth will rely on the byproducts, the simpler micromolecules generated and produced as source of energy for their growth. Okay, and then next we have the acidogenesis, where we normally refer to this as fermentation process. Okay, the hydrolyzed products, the macromolecules produced from the liquefaction. Okay, production of the simple macromolecules like glucose. Okay, and then this is going to be fermented further for production of volatile fatty acid and also alcohol. Okay, so normally most carbohydrate will end up as in the form of acetic acid, fat, and also protein metabolism still form higher fatty acids, something like propionic, butyric acid, and also volatile fatty acids, VFA. And then methogens as well at this stage through acidosis process, producing acetate, carbon dioxide, as well as hydrogen. Okay, so the acetate, carbon dioxide, and hydrogen are the one important substrate for the methane production. Okay, and then it goes to process of acidosis, acetogenesis. So the methogens byproduct produced and coexist will come into association with another types of bacteria, the acetogens. Okay, so the methogens would be the one that generates the methane, and the acetogen or acetogenic hydrogen producing bacteria will help to further degrade the alcohol and fatty acid to produce and generate hydrogen as well as acetic acid. Okay. Some of the estrogen microbes are, we have the Centrobacter polymi, Centrobacter wolfram. Okay, these are the one that converting all this, what you call it, alcohol or this fatty acid into hydrogen, as well as acetic acid and also carbon dioxide. Okay, and then lastly, you have the methanogens that forms methane from either hydrogen as well as carbon dioxide or acetic acid. So these are the list of methanogenic microbes, bacteria. So biogas may require further treatment with other chemicals like ferrous chloride, okay, ferrous chloride, to be included into the digestion tanks to inhibit the accumulation or production of hydrogen sulfide, which is not needed, because this hydrogen sulfide is the one that gives you the faulty smell. If you look into the drain, you get to smell something unpleasant. That is the production of hydrogen sulfide, which is a toxic product from the sulfate in the feedstock and then released as trace component of the biogas, which is not needed. Okay, these are the construction, classification, as well as operation of the digester. That you see the digester being what you call it, manufactured and constructed. Okay, the digester, where it helps in, what do you call it, anaerobic digestion process. Okay, so these are the process involved, where you can collect the biogas. Okay, so once you open the lid, you dump in all the raw materials into the digester and get it to be evenly layered. And then human and also the animal waste is then added to about 2/3 of the digester and inoculated with the bottom layer of the oil batch. Okay, so you put back the lid on top of the place, and all the pipe connection will be sealed. So normally the biogas production will start to generate after 3 to 5 days or 7. That one is during summer. But then again, in our country, we don't have summer or winter, so it's throughout. Okay, so should the generation of biogas be too slow, then again, the pH might be too low, then you need to adjust it using the lime to make it more what we call alkaline. Okay, because normally microbes, some of these microbes are much more effective with pH close to 7. So for stable biogas generation, you need to add in raw material every 10 to 15 days. Okay, so at every feeding process or cycle, an equal amount of liquor is needs to be discharged, and then the raw materials need to be added further. So the process needs to be done carefully to keep the liquid level above the outlet in order to avoid any release or escape of biogas. So every year, the digester will be discharged completely once or twice. Okay? And then before discharging the all material for starting, the new batch must be readily available. All right, so these are the daily thing, important steps when it comes to anaerobic digestion. To help speed up the digestion, it needs frequent stirring of the digested liquor, and then maintenance of proper pH. It needs to be close to alkaline. You add it with a lime. Okay, so and then control of water. water is important, but then again, too much of water will not making the anaerobic digestion successful. So water levels needs to be regulated. And then just need to check on the leakages if there's anything at all the connecting pipes. So normally for what you call a six digester or digester that's not performing well is something to do with the water as well as the gas leakage. Okay, so normally the plant for the anaerobic digestion will undergo thorough cleaning of the soft cracks, no sorry, filling to ensure that there's no water and gas leaking, and then add in a second layer of concrete to avoid further the leakage, and then checking all the connecting parts to make sure all are gas tight, okay, and not causing any gas leakages. So this is the byproduct of the anaerobic digestion, the solid, and also the methanogenic digestate. Okay, so these digesters are remnant of the original input materials to the digester, where this digester is no longer able to be used by the microbes. So normally it consists the mineralized remains of the dead bacteria, the cells, and the biomass cells, and also, and therefore, from these two types of waste, the byproduct, one is the acidogenic digestate, the solid. This one is a stable organic acid, normally consists of the resistant lignin and also cellulose. Some plastic may be able to be present. So this can be used as compost and also to make other low-grade building materials like fiberboard. Okay, and then you have also the methanogenic digestate, the liquid. Okay, this one is rich in nutrient, and then this can be used further as biofertilizer, which is rich in nitrogen, phosphate, as well as kalium. Okay, this is an example of commercial biogas production center available, huge scale, industrial scale, where normally it's being placed nearby the resources. Okay, farmer produce and use their own energy and fertilizer production. So maybe one last glimpse, get to see this video.
We know what you're thinking. You hear the music, see these amazing places.
Let me stop sharing the slides first, and then we share the video. Okay, can you see this?
This is on Earth, and you think we're going to talk about another big idea that might or might not happen to save it. Well, no. We are here to share with you something practical that we have actually built to bring what people say for years is the future to right now. Food waste and declining energy sources are major environmental hazards. Biogas is the solution. It's a natural process in which organic waste is converted into cooking gas. So 5 years ago, we went on a mission to bring biogas to every home. We grouped the best engineers, scientists, designers, and product people together. And now it's here. Home biogas. Home biogas is the first family-sized, user-friendly, affordable biogas system. It is the change, and you can put it in your backyard. Home biogas comes in an easy-to-assemble kit, and its use is as simple as can be. Just throw in your organic waste, and there you go. Hot stove ready for cooking. A cycle of in-house energy, and it runs with no electricity. Your leftovers provide you 2 to 3 hours of energy a day. Any kitchen leftovers, including meat and dairy, work, even your pet's litter. Just toss it all inside home biogas, and the bacteria in the digester will decompose the organic material and release biogas. As a byproduct of the digestion, home biogas even generates an incredible plant fertilizer. It's the kind you pay a large sum for in garden stores. In this manner, home biogas creates an eco-cycle. Waste turns into gas and fertilizer. Fertilizer is used to grow food, and gas to cook it. Leftovers are more waste. We are way past this. We've already installed more than 150 units that have been running for over a year. Until now, we've worked with international organizations in underserved communities. Now we're bringing it to you. You are in charge of creating your own clean, renewable energy, energy that you can trust. We need your help to make home biogas an accessible household item. So if you want to bring the change, get home biogas. Let's create a better future for our next generation. The world was entering.
All right, so that's about it. Stop sharing this one. I think that will be the last slides. That will be the last slides. So this ends our class today. Okay, so I hope that everyone will have a clear idea. I'll try to share with some of you on some of the papers available on this what do you call it lecture that will be useful, and I will help to put it up in our in it so that you can go through it. Okay, go through it, and then you can study to understand further some of the. Let me share with some of you before we end the class. Sorry, before we end the class. It seems to be able to finish. Okay, let's stop sharing this one. Okay. So I'm thinking of showing you some of the one that I mentioned. I will share some of this paper. Can you all see this? You need to close down some of the thing. It's too many. So too many so that again it's not being. Okay, so this one, this is one paper. Interesting recovery, resource recovery, as well as circular economy from organic solid waste using anaerobic and also anaerobic digestion. It's a very recent paper in 2020. Interesting paper about the current situation, the challenges. Okay, so you can go through some of these. Another one will be, hang on, the one will be energy digestion for recovery. This one is also something interesting. Review. Okay. Maybe can you see this? So I will share some of this, and I will have a few more to put up, and then have it in place in our edit for you to go through and review it. Okay. So these are the things. Before we end, I'm going to share again the QR code attendance. Okay. Just in case for those of you missing, logging in earlier on, you can log in again. All right. Okay. I think we have come to the end of our class today, lecture today. So thank you very much for your attention, everyone. Okay, and then we're going to meet up again next week. So stay safe. Okay, and then thank you very much. Okay, Assalamualaikum warahmatullahi wabarakatuh, and thank you all.
Thank you, Doctor.
Thank you.
Thank you, Doctor.
Thank you.